Jai Hind viewers, welcome to AKGEC Digital School. My name is Pankaj Singh, faculty of IT department. Today I will deliver my video lecture on subject operating system and topic is memory management paging. So let's start. It is a topic of 4th unit. So first of all we will understand what is memory management and why we need it. What is memory management? As the name defines, to manage the memory we have to follow some set of rules and we also follow some techniques to manage all these things. So first we understand what is memory management and why we required it and what are the key parameters that will helpful to manage the memory. For achieving the multiprocessing in a computer, operating system use memory in a best efficient way. For efficiently using the memory, it use two concepts here. One is paging and segmentation. So how paging will work and how segmentation will work, we'll discuss in detail in next slide. But before that, we understand the actual memory management parameters and features what are required. As we know that operating system reside in a main memory. Main memory consists two division in which one half is used for OS functions and second is used for memory management functions, or we can say operations. When we start a system, OS is load to the main memory and other space is used for the other memory management operations. I read the second line here. Memory management is a method in an operating system to manage operations between main memory and the disk during process execution. The disk may be here is a secondary memory. The main aim of memory management is to achieve efficient utilization of the memory. How to we use it in a best method, or which method is best suited for a specific process access or to execute the operation. That is, all operation is done by in a memory management part. Why memory management is required? As I said earlier, where it will be helpful and how it will work. There are few points I have reading. Allocate and deallocate memory before and after process execution. As we know that when a process is executed, or we know the whole process cycle, after the termination of a process, it will relocate, or we can say the new process will load into the main memory and the previous one will be relocated to the secondary memory. How it is done, that is also a part of memory management. Second, to keep the track of use memory space by a processor. Thirdly, to minimize the fragmentation issues. As we know, fragmentation is of two types, internal and external. Internal fragmentation lie when there is some space will left within a memory. For example, if we have a space of 4K and the process kept only 3K, here 1K is left, it is known as internal fragmentation. And when we place number of process in a main memory location, and if any process is not lie within a main memory, such type of fragmentation is known as external fragmentation. For that I will take here a example in the next slide. Third one, to proper utilization of main memory, that is also managed by the help of memory management. And the fourth one here, to maintain data integrity while executing of a process. So all these parameters is maintained and required at a time of execution of a process. So memory allocation, as we know that is also discussed in a data structure. It is done, memory allocation done in a two method. First one is contiguous and second one is non-contiguous. In contiguous, we allocate a common area space in which same type of element is stored, just like a array. And in a non-contiguous, generally we use a linked list to allocate a memory space within a memory. So here is a concern, non-contiguous memory allocation, how it is done within a machine. That is done by the help of two methods, as I said earlier, that is paging and segmentation. So today's our video lecture main concern is on paging, how paging is work and what is paging, how it will execute. So before going to the paging, I here know the method of a, or we can say difference between paging and segmentation. Paging is a static method, whereas segmentation is a dynamic method. In paging, a process is divided into a fixed size of block, or we can say specifically page. But in segmentation, a process is divided into a dynamic size. Okay, so it is a basic difference. It is a machine drive method, or we can say done by the CPU. It is a user method, means I will discuss it in detail here. In segmentation, for example, now we take a process P1. In paging, process is divided into a fixed number of pages, fixed size of pages, for example of each of 2K, 2K, 2K and 2K. Total is of 8K. But in segmentation, the same thing will do, like the first part may be of a 2K, next part may be of a 4K, and the other two part may be of a 1K and 1K. In this method, we don't need to identify where is a program logic lie, or where is a all functions lie within a same partition or not. But in this method, segmentation, we divide a program according to the requirement, in which we can easily partition the program as per own requirement, or we can say as per the functionality requirement. So it is a basic difference between paging and segmentation. Now come back to the paging. So how paging will work? It is a concern of today video lecture. In paging, secondary memory and main memory are divided into a equal size partition. What the meaning of equal size partition? In both, the page size will remain same. Means the process will contain the same size and the main memory will contain the same size. Next, the partition of secondary memory process are called pages, and the partition of main memory are called frames. Frame size equal to the page size, as I said earlier, or vice versa. These both are dependent to each other. The value in paging will remain same. If page size is 2K, then the frame size will be 2K, and if frame size is 2K, then page size will by default will be 2K. That is the major requirement, or we can say the dependency of a paging method in a memory management. So that will keep same in paging, but will differ in fragmentation. So now take a here example. As we see the secondary memory here, the partition is represented by the term page, and main memory here represent by the name of frames as represent in a PPT. So how it will exactly work, we'll understand easily by the help of a example. Here we consider or as an example given, in which we have a 4 process, or we can say 4 pages of a main memory. So first I read the example here, then I will explain. Consider a process is divided into a 4 pages, P0, P1, P2 and P3. Depending upon the availability, these pages may be stored in a main memory frames in a non-contiguous fashion as given. So if we have a process that is P and it is divided into a 4 pages, P0, P1, P2 and P3. Now it will place into a main memory. So how it will place, as given in a figure, as we see the P0 placed here, I mark the frame number F0, 1, 2, 3. So in main memory, the first page, that is P0, is placed at a frame number 0. Likewise, P1 is placed at a location of frame 0. P2 is placed at a location of frame 3 and P3 is placed at a location of frame 1. So what it represent here? It represent a non-contiguous allocation of a memory within a main memory, how it will placed. So what it give here illusion that the memory, whole the process is placed in a main memory, but the order is differ. Why it is differ? Because maybe at the time of placing P0, the location is occupied by another process, or we can say page. So that will allocate or accumulate at a location of frame number 0. After that, when a page number 1 arrived, that will stored at a location of 0, but in a frame location of 0. Likewise, other pages will accumulate into a main memory. So now take a detailed example, or before going to detailed example, we know the terminologies or the terms which are used in a numerical. Like there are 2 terms generally used, or we require the conversion of a address, that is a logical address. One term is used as logical address and second term is used as physical address. So where these terms will lie, or who will generate logical address and who generate physical address, and where they are used, we know before going to a detailed example of these. As in a point given, CPU always generate a logical address. Logical address is always generated by the CPU. CPU don't know the exact, or we can say the physical address of a main memory. It generate logical address, and physical address is needed to access the main memory. Thus it is required to convert logical address into a physical address. When a CPU requests for any data, it send or it transmit logical address, and this logical address will convert into a physical address, and the major this process of conversion is done by the help of concept paging. In paging, the address is divided into 2 parts. What are these parts? In logical, the address is divided into 2 parts. First one is page number and second one is page offset bit. Similarly, in a physical address, that is also divided into 2 parts. First one is frame number and second one is frame offset bit. One thing here to remember, the page offset bit will remain same in both the cases. That is the actual content required by the CPU, but the page number and the frame number are differ. To match or to identify, or we can say to convert a page number into a frame number, we required some mechanism. This mechanism is known as paging, and in paging this is done by the help of page table. What page table contains? It contains the page number against the frame location where it is placed into a main memory. So hopefully it is very clear what is the basic difference between logical address and physical address. I repeat here again, logical address generated by the CPU and physical address is required for a memory to access or store the required content into a desired location. Now we take an example, or before going to example, we here understand how it will convert, or how a logical address is converted into a physical address. For example, we have a process, we take the same process P that have 4 pages, P0, P1, P2, P3, and that are placed in a in a page table at a different frame location, that is F0, F1, F2 and F3. For a time, don't consider it. I write here some page number. For example, P0 lie in a location of frame 3. Likewise, P1 lie at a second position. Similarly, P2 lie at a P1 lie at a same position and P3 lie at a 0 position. So how it will find out the concerned page number? For example, if CPU required only a part or the code written in a page number 1, so it will request only page number 1. We have only 4 pages, so what will be the exact binary representation? For the first page it is 0 0, for the second page it is 0 1, for the next page it is a 1 0, and I write here page number, right? When CPU requests P1, that means the binary representation of 0 1. Okay, so 0 1 will be identify, or that will be the logical address, but 0 1 is placed at a location of frame number 2, for example. So what is the exact order of a frame number 2? If we have the same 4 frame here, that is 0 0, 0 1, 1 0, 1 1. So we will find out that in a main memory that is placed at what location? That is 1 0, means page number 2 placed in a location number 3rd of a main memory, or that is the frame number of a main memory. As we see in a given diagram, the offset bit will remain same. What? That is the actual data required by the CPU for a concerned operation. Here the page table will identify to the exact location of a page into a main memory in term of a frame. So that will convert into a 1 0, and along with the offset bit is also added. Like this method, CPU identify or send a request in which this operation is executed by the help of page table, and these all operations is maintained by the help of paging. What are the advantages and disadvantages of paging? As I read here, a single process is divided into part and stored each part in a non-contiguous fashion. It overcomes the problem of external fragmentation. In this method, external fragmentation is overcome. We can't say it is totally avoided or that is not possible, but that is overcome by the help of paging, because we divide a process into a equal size of pages, and then we will place into a main memory. That is also in main memory, the frame will be also the same size. As I said earlier, frame and page size will be same in paging. And there are some disadvantages. There may be a internal fragmentation, and there is a need of maintaining a page table for each process, because if the number of process that is directly equivalent to the number of process, if we have 10 process and each process is divided into a number of pages, then we will maintain a page table for each process. Thirdly, the time taken to read the instruction increase as it required 2 memory access. But obvious, if the number of pages increase in a number of process, then the page table will increase and it will take more time to access 2 memory location. First one is in physical address location and second one is logical address location. There are few terms generally used in a numericals. These are physical address space. What is physical address space? That is actually the size of main memory. In few questions it is defined as a physical address space, so don't be confused here. That represent the size of main memory. In few questions, size of main memory. What is size of main memory? If we have the frame and page size, we can easily calculate the size of main memory. Or for example, we don't have the page size, so how it will be calculated? Page size will be main memory size divided by total number of frames. Very easy. And I repeat here again, the frame size always be equal to the page size, or page size must be equal to the frame size, or we can say vice versa. That is a minimal requirement of a paging numericals. Now if we consider or take a small numerical here, if a process, we can say P, or we can say P1 of size 4K and main memory size is of 16K. So one parameter is also required to identify the location of the process in a main memory, that is page size or frame size. Frame size in a main memory and page size in a process. For example, if page size is 2K, so how many pages is required to store a process P1? Very easy. Number of pages required size of process divided by page size, that is 4K and that is of 2K, 2 pages. So process P1 consists 2 pages 0 and 1. Okay, these are page number. Likewise, what size memory, main memory we have? That is of 16K. So 16K memory will divide into how many number of frames? Very easy. The frame size and page size must be same. So what it will be? The number of frames will be main memory size divided by page size, or we can say frame size. That is 16 and that is 2. That means we have 8 frames. That is F0, F1, F2, F3, F4, F5, F6, F7. Likewise, page number 0 and page number 1. In paging, for example, the frame 0 is already occupied by any process, frame number 1 also occupied, frame 4 also occupied, and frame 7 also occupied. So where we place our pages of a process, that is P0 and P1. As I said again, the size is same, that is of 2K. So page 0 placed at a location frame 2 and page 1 placed at a frame 5, P0 and P1. So these details are kept in a page table, page number and frame number. What is page number? 0, 1, where it is lie in a main memory at a F2 and at a F5. That is the actual implementation of a process. First, it will divide into number of pages, and likewise main memory is divided into number of frames, and then we map the pages into a main memory. Why it is called non-contiguous? As we see, this space is already occupied by another process, and we don't have a continuous space to store a process in a single slot. So it will stored at a frame number 2 and frame number 5. So when we call for example page number 1, that is 0 and 1, when it will pass, how it will convert into a, identify the specified location into a specific location frame number 5, and it will return the data to the CPU. It is a detailed example of a paging. Hopefully it will easy to understand to all of you. Thank you. We will meet in a next representation or next video lecture.